Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So this week I want to take a look at making an improvement on one of the metal lathes that we took a look at in the video, I think 2 weeks ago at this point. Let me show you. So I've really been enjoying using this smaller lathe for, well, smaller stuff, but there's a number of improvements that I would like to make on it. And the thing I want to take a look at today is the way wipers. That's this piece here and this piece over here. And what they're designed to do is to keep chips and other stuff that comes off of whatever you're turning, so that's going to be mounted up here in the chuck, from getting underneath the carriage. Because what you want is a nice smooth surface on the underside of this carriage sliding against the nice smooth surface of these ways. And the carriage slides against this surface up here, which I think is 45 degrees, and this flat surface back here. Now it's nice and clean now, so as we move this back and forth, no issues. But when we are turning material, and that breaks off into small pieces, it falls all down in this area. We do not want that getting underneath the carriage. Particularly things like cast iron or other materials that are also hard and abrasive, because it's essentially like trapping sandpaper underneath there. And even though this is hardened, I don't think the underside of the carriage is hardened, and that's going to wear, and then this is not going to be accurate in the future. And I don't think these way wipers are doing very much right now. Let me get you down there closer. Okay, I brought a light over as well so we can hopefully see what's going on. It looks like the current way wiper setup on here consists of a thin piece of sheet metal that is bent into this shape and a piece of felt behind it. But what I noticed is there's a pretty big gap there. Like, I don't think it's doing much of anything right now other than trapping material in there. And maybe we could kind of push that felt down into place. Like if we loosen up this screw, maybe we can push that felt down against this surface, but that felt is still really just going to trap contaminants there and then drag them back and forth across this surface and potentially still end up getting them trapped underneath the carriage. And if we look at the rear one, that one doesn't even seem to cover the whole surface of the way. It actually does look like maybe the felt is at least touching on that one. Let me move the light. Yeah, it does look like the felt is at least in contact with the ground surface of the way there, but you see it doesn't extend all the way over. Like there is a significant section there on the side where material can just get right underneath of it. And same thing, I think that felt can potentially trap material, again, like cast iron or something abrasive, and just drag it back and forth across the surface and eventually let it get trapped underneath the carriage. There's a very different system for the way wipers on my larger lathe that I think we can essentially adapt, well, not adapt, but sort of steal the rough design of and make new parts for this lathe. Let me show you. So if we take a look at the carriage on this machine, notice this one has, I believe these are actually rubber way wipers, and they have sort of a feature that comes down to the front that extends a little bit past, that is pushed pretty tightly against these prismatic surfaces and the flat surface back here. And as I crank this back and forth, you can see that does a pretty good job keeping those surfaces clean. Anything that's on there, like that's just a little bit of dust, and it's still sort of squeegeeing it up here, and we're getting the same effect here on the front. You can see sort of the line of oil actually get pushed by that rubber wiper. So I think that's what I want to try and do, and I think we can do it with TPU. I think TPU is going to be resistant to any of the cutting oils or lubricants or anything that we typically have on the lathe. And I think it is going to be flexible enough to make a nice seal against these smooth metal surfaces. I don't think it's going to be as soft as this rubber, although actually this rubber's pretty, you know what? I would say the durometer of this rubber is probably pretty darn close to the SaneSmart and Sunlu TPU that I have. So, all right, let's go back to the lathe. Let's get some measurements and think this through. So we have two here on the front, and they're a little bit tricky to see, but we have, I think, mirror images of those here on the back. They're underneath the DRO, so they're a little bit tricky to get to. But I think we can just basically take the same design that we come up with for the front and just mirror it and use the same thing for the back. So let's focus on the front. Let's get these off and see what's actually under here first. Okay, so here's what we took off of there. The rear one isn't so bad. If this one was wide enough, this one probably would have done okay, because it's just a flat surface And I do notice there is some metal shavings sort of caught in the front of this. So this one was kind of doing an okay job, but the front one for the 45-degree way, like this one's not doing anything. And I think it's just the shape of it. So it's cut here to allow for those screws to pass through. But that means there's nothing really pushing these side faces on there. And that way is not, it's not actually 40, well, I think it is 45 degrees, but it's flat at the top. So there's this huge hole basically at the top that's never going to seal with the way that this is designed. And there's really nothing trapped on there. I think thus far, everything was just going underneath the carriage on that side. So that's not very good. I think we can probably use these metal plates as sort of starting dimensions to at least get like the position of our screw holes, for example, on this one relative to the position of those faces on the ways. Again, as a starting point. I doubt that's going to be perfectly accurate, but we can start there. And I think we'll replace the hardware as well. I'm not a huge fan of these Phillips head screws on there. And if you're wondering how the carriage is going to stay lubricated if we're wiping all of the oil off of the ways, you don't actually lubricate the contact area between the carriage and the ways by lubricating the ways. The actual lubrication between the carriage and the prismatic and flat way is done through these oilers. There's one here, there's one back here, and there's one down here. So we're injecting oil into those 4 oilers on a regular basis, and that basically keeps a thin layer of oil between the faces of the cast iron on our carriage and those prismatic ways. All right, and while we're over here, I grabbed this piece of felt so you can see what this was doing or really not doing. I mean, first, the angle of it is not even cut exactly straight, and it does not come all the way down the front or the rear of that prismatic way. And there's a big gaping hole at the top because it's cut in a V, but our way here is really not a V, it's flat topped. And same thing on the casting, it's relieved there at the top where this was probably ground. It was probably machined and ground. Now there's not a huge gap between the casting and the flat surfaces of this prismatic way. But at the top there, that is 3, maybe even 4 millimeters tall, that gap there. So material is absolutely going to get inside there, get ground down, and then work its way down onto the flat surfaces of the ways here, which is what we don't want. So our design should incorporate a tight fit to both sides of the prismatic way, and then also wipe the top flat surface, just like on the larger lathe that I have. And the back one, I think that one's going to be pretty easy. We just need to make sure that we actually come across all the way so that we're wiping the whole flat surface and not just, you know, sort of a token area over here on the side. All right, and here is the initial design that I came up with so far for this wiper. And I'm just focusing on that one spot in the front that we took the old one off first. I want to figure out as many elements of the design as we can before we start trying to think about the other ones that we need to design as well. And I know that I'm not going to get all these dimensions right on the first try. Not only am I measuring something that's very difficult to measure, I mean, I'm not even sure we have the right angle, although I'm pretty sure it's a 45. But this is not going to print exactly the way I've dimensioned it. We're going to make this out of TPU, so we're not going to get hard corners on anything. And I don't know for sure how pliable the material is going to be. I can guess based on my experience with working with it before, and that's why I've kind of chamfered this. I want the front edge to be thin and pliable and make a good seal, almost like a squeegee on the metal way of the lathe. But then I want it to sort of stiffen up as we approach the mounting plate back here, which is also still going to be TPU, because we're going to need a little bit of flex here. I'll probably tighten one side and then kind of push down on the opposite corner to flex to make sure that we're getting good contact on all the surfaces. So yeah, I guess, long story short, there's a lot of unknowns here. Don't spend too much time trying to get everything perfect, because you're probably gonna have to come back and make a bunch of changes and undo a lot of the sort of quote unquote finishing touches that are tempting to put on an item. I did round the corners at the top. I don't think those are going to be in the way. And at the end of the day, I don't want this to stand out and look like an afterthought on the machine. Ideally, it should look like the machine just came with it. So I am also looking to kind of match the look and feel of the other stuff on the lathe as well. And I want this top face to line up with the bevel that comes down in the casting. So we can knock those things out as well, in addition to try and getting our fit over here. So, all right, I'm going to print this out and I'll bring you guys back. All right, and our first test piece is done, and it came out really clean. Printed this on the Cheaty Plus 4. Been doing a lot of flexible material on that machine so far with pretty good luck. Been doing some flexible PLA as well. I contemplated doing this part in flexible PLA since the flexible PLA I have is actually softer than the TPU that I have. But TPU is really impervious to lots of different materials, even gasoline. Like I've not found anything that I've exposed TPU to that it has changed it in any way that made it less useful. I mean, I'm sure there's something that dissolves TPU, but I haven't found it yet. All right, so let's see how this fits on the machine. I think I also want to change the hardware out. I'm not a big fan of these Phillips head screws. These also don't look like the highest quality screws. I noticed the heads were kind of moving around in a not particularly circular fashion when I was taking them out. If you watched last week's video, I showed my thread identification tool set, and I linked to it. And you guys actually, I think, sold Amazon out of the one that I linked. I checked the link earlier this week, and it was actually going to a different set. But yeah, if you bought one of these, make sure that you got the right thing. Because, and I find this the case on Amazon a lot, if I link to something and it sells out, the manufacturer will often default the link to something else. And I think the link that it was defaulting to was one of the like red and blue aluminum ones that I said don't get. So I did update the link, and I'll link this again down in the description. But yeah, if you bought one of these in last week's video, make sure you got the right one. If you got a different one, just send it back and get this one. Okay, so this is indeed M3. It's M3 by 0.5. I'll link this down in the description too. I have a bunch of different sets of these. This is, I think, M3 to M5 in button head, which should work well for us. Let's see, this is M3 by 8. We probably don't need 8 long. Actually, yeah, the original ones are even longer. I don't know why they're so long. I bet you the 8 is plenty long enough though. So let's try 2 of the M3 by 8. Well, it looks like it fits against there pretty nice. Okay, it's contacting okay. This is already significantly better than what was on here, but if you watch when I was pushing the oil along there, particularly on the front face here, it's just getting sucked underneath, which if there was fine dust in that dust is going in there with it. So I think we need to be thicker on this. I just went and I looked at the other lathe and I noticed that they're significantly thicker than this. I was thinking keeping it thin so it's flexible, but I think we need to keep this part thick back here so that we have a good structure that's keeping constant pressure on this when we tighten it down, and maybe have just the front section be thin. So maybe we'll have just a thin section that extends a little bit further than our base. And I'm noticing we're not making great contact here in the corners either. I got some ideas for that, but let me pull this one off and I'm going to go do a V2. All right, and here is version 2 of our design. And I did bump out the top a little bit. It's only bumped out about 1/4 millimeter, so I'm not entirely sure how well that is going to print. I mean, it's not a large overhang. It's only like 45 degrees. But I'm just not sure exactly how that transition is going to work because we still want a nice smooth surface here to actually seal against that way. And I just did the rest of the dimensions, give us a little more clearance here at the top and tighten this up so that hopefully this thing should be a much better fit along there. So, all right, let me get this printed out and I will bring you guys back. All right, and here is our V2. And boy, that step is not very tall. It did print. I don't know if the light is picking that up. Yeah, you can see it there. But we've got all these weird artifacts on here now. It's tough to see. I'm trying to get it to where the light's shining on it the right way there. Can you see that? It's like a bunch of wrinkles in the surface. It's more down here on the part that I'm not so concerned about than up here on the flat part. Yeah, it's up there a bit too. So, yeah, well, let's try it. Well, it definitely seems like a nicer fit against the prismatic surface. Although, you know what? Just noticing, I didn't catch this before. I don't know if you guys can see it with the light. This corner is extending all the way down into sort of this little flat trough down here. This side should be shorter. This side we want to extend past so that anything that is here at the edge just gets pushed down and falls off that edge. This side, I think we only want to be basically the distance of that flat surface, because right now the corner is extending all the way down into that trough, and that's just going to push things along and may end up dragging them back in this direction as well, which I guess could potentially cause it to get trapped in there. But either way, let's try the fit. Okay, that's definitely working better, but I don't know if the light is hitting it that you guys can see it. It's wiping down here on the bottom and up at the top edge. The top face actually looks like it's getting mostly wiped. The backside looks really good. The flat face here on the back, that is getting totally squeegeed off. All right, so I got to figure out how we can adjust the geometry here that we're getting a better wipe on the top surface, because right now it's curved. Like this comes up to an abrupt corner, but our print is curved there. And I think unfortunately, I think what's causing the front face here to not wipe very well is, yeah, it's up at the top. It's like 2/3 of the way up. That's exactly where that artifact was in the print. So that's probably what's causing that. But otherwise, this looks pretty good. So, all right, I'm going to shorten up that back and see if I can adjust the geometry to give us a tighter corner here where it meets the top. All right, our next print is complete, and I think we solved some problems and unfortunately made some new ones. I think we're good over here on the shorter leg. If you notice, that side is much shorter now. And if I put this on here, yeah, that extends down to the bottom of that flat face now and just not into that flat trough at the bottom, which is what we want. The geometry at the top seems to fit tighter against the top of that surface. The way I achieved that was I actually sort of pulled the corners back up and in a little bit so that the extruder has to travel sort of up towards the top face just a little bit, and then same thing on the other end. It travels up towards the top face a little bit before it comes down. And that's given us a really nice geometry there. I don't know if there's enough light here for you guys to see that well, but the artifacting there is now even worse. Let me go back over to the bench where you guys can see better. Okay, yeah, over here at the bench, I think you guys can see that better. You see the wrinkles on that surface there? So, again, we got the geometry right now, but by causing that toolpath to pull back up, the extruder is now going around, let's see, like 5 or 6 extra corners instead of just the 2 corners here. So we solved one problem, caused another. We had some of that before, but it's far worse now, and I'm pretty sure it's an extrusion issue. I don't think it's flow. I did adjust flow up a little bit, just looking at this top face on the previous print. I think I'm at 102% on flow now. I think that might be pressure advance. I bet you the pressure advance just isn't perfectly tuned for this filament. And I think we're now seeing that by causing it to go around all those corners. The pressure advance is probably kicking in now, instead of twice, kicking in like 8 times. And because we're not perfectly tuned, I think it's just making a mess of that. And unfortunately, we really do need that to be a smooth surface because it's got to wipe those flat ground surfaces as it slides along. And I cut this back. The way this is designed now, as this wears, we can just loosen those screws and slide this down. And you know, that said, I bet you this TPU wears really slow in this application. But by sloping it back, there should always only be a small portion that is in contact with the way. At least it hasn't already worn in. I mean, as this wears down, we can assume that it's got a perfectly flat surface that mates against that metal, but we don't want new material that's not worn down to the right shape touching. So yeah, I think I'm just going to go tweak the pressure advance settings and see if I can get that to come out nice and smooth. Okay, I ran another one. It looks like we've moved that area a little bit closer to the corner. So I think that confirms it. I think it is an extrusion issue and not like a toolpath issue. So let me run another one, see if I can get it. All right, ran it again. Managed to shift it further out of the way. It's a little bit confusing. Shifting the pressure
ran it
advance
again
and further out.
another
This
one.
is confusing. It looks like we're sort of back to close to the original position, a little bit closer to the corner. So I think that confirms it. I think it is an extrusion issue and not like a toolpath issue. Do you know why you're here? Let me guess, is it because I didn't make a clickbait video bashing Bambu like all the other cool 3D printing YouTube channels? You know, I don't agree with what they did. I just didn't feel the need to make a video about it. People can make their own decisions. Sit down. It says here you printed the same STL 27 times. I'm sure it wasn't that many. Well, you know, I thought I was just like one tweak away from the perfect print, you know? All 27 times? Yeah, all 27 times. What is this anyway? It's TPU. Of course, that's fitting, I guess. Would you please just go and calibrate the filament FPF? All right, guys, that was quite the wild ride. These parts are not from the Cheedy Plus 4. These parts are from my Bambu Lab X1C. Same TPU. You saw me doing the pressure advance calibration on the Cheedy Plus 4. And when I ran the prints using the results of that calibration, the results were about on par with the best that I had gotten just manually tweaking it. So I think there might actually be an issue on that Cheedy machine with either the implementation of pressure advance and clipper, which seems unlikely to me, or the extruder itself. It probably comes down to something in the extruder. Now, I don't want you to think you can't print TPU on that machine. I've printed a lot of flexibles on that machine, and I've never really had this issue before. I think it comes down to the toolpath that we're asking the machine to make in combination with pressure advance, and just, I don't know, maybe the distance between the top of the heat break and the extruder gear. I'm not sure. I ran these on my Bambu Lab X1C. This is actually the second attempt. The first attempt, I let it do its auto calibration where it prints little squiggles on the bed and then reads it with either the LiDAR or the camera. And those came out pretty good. I'd say they were on par with the best result I got with the Cheedy Plus 4 on the first try. But then I did the manual pressure advance calibration on that machine, the same way I did it on the Cheedy Plus 4. I put that value in, which was higher than I expected. And yeah, these are darn near perfect. There is still a little bit of a squiggle there, but not much, and it's not very deep at all, and it's consistent. I've printed, I think, 4 of these now. This is the same part, just mirrored, because we need one for each side of the carriage. But yeah, I kind of wish I had just switched to that machine earlier in the process. I probably would have even been happy with the automatic calibration result. But hey, we got there in the end. These parts look great. Let's go try these on the machine. Wow, that looks great. We have a little bit of a line right up here at the corner. Yeah, the back face is completely wiped clean. The top flat is wiped clean. There's a small little line right here at the top on this flat face. Let me just see if I can tighten that down a little more. I'm just going to loosen this side. And there we go. That is perfect. Let me get you guys out of the tripod. I'll show you. We are completely clean on this face, the top face, and the rear face. That looks really good. So I won't bore you guys with putting the other side on. That should fit just the same as this one. It's just mirrored. But I do have to go whip up a design for the rear. That shouldn't be too hard. Let me go do that. I'll bring you guys back. All right, I went through 2 quick iterations on this. This is the first one. I actually printed this one just in PLA. Because my A1 Mini is over here and PLA prints real fast. Just test the fit and lineup of everything. And the only thing I had to tweak was I shrunk the size of the mounting holes a little bit, brought the top face down, and I pulled this one back the same way, where this drops back at an angle. But what I noticed was that sort of leaves a little bit of a notch like open down here in the back. It still pushes everything clean off, but in sort of reversing the carriage, I didn't want a gap there. I was a little worried that something might sneak underneath there, so this is the final one printed out of TPU. And if you can see what I did there is right at the edge, right at the, so it's pulled back at maybe, and I think it's like 15 degrees for the majority of it, but right at the edge, it comes down flat. Hopefully there's enough light here that you guys can see that, so that when this is in place, it seals up that gap. It pulls all the way back to the casting, so that nothing can sneak in there behind it. Screw this in. Yeah, that looks great. It is wiping it completely clean. And I think probably want to overhang this edge by just a little bit. I have it right flush. There should be just enough room here in the screws. Yeah, I could slide that over like just 1/4 of a millimeter. All right, to get you guys a little closer so you can see what's going on. As I back up, you can see that is totally clean. There is nothing on there at all. I don't know if you guys can see that. There was actually a bunch of grit underneath that was getting dragged along by that felt. Okay, so the front one here on the other side of the carriage is working really well. You can see how well that wiped everything off. It's a good fit down there. The rear one doesn't quite fit. I didn't notice this. The cable coming out for the DRO head is pretty close to the casting, and the original way wiper was thinner than our design, and it did sneak back there. This one doesn't quite fit back there. It feels like it's close. I think if we just shave a little bit off the top, we should be good. Now, obviously, we're not going to be able to modify this one since it's TPU. But I'm just going to go in and probably knock 2 millimeters off of this flat surface above where the screws are, and I think that'll get us there. I'll bring you guys back. All right, while we're waiting for that to print, I just realized I actually have a package we can open up here. This is the other lathe from that comparison video we did a couple of weeks ago that had all kinds of issues, and the lead screw on this machine is bent, and the side cover is split. Actually, this just came earlier today. All I did was just peel my address label off. Let's cut this open. Let's see what we got. All right, so this should be a replacement lead screw and side cover. And I guess it's interesting the way that they sort of taped this box up and made their own size. I don't know if maybe they saved money by not shipping the air that would have been here. I don't know. There's actually, I think this is the lead screw sticking out of the side here. I wonder, can this just be pulled out? That might be against the side cover. I don't want to damage anything. You know, this might have actually started off inside the box. I kind of assumed it was sticking out. I don't know why. It just made sense to me that that's how they would send it. I think there actually was enough room here in the box. This probably got dropped and came through the side. Which means it probably damaged the side cover. That was the replacement side cover. Yeah, I mean, it got beat up on the way, but actually looks pretty intact. I don't know what any of that means. You know, guys, I gotta say, the lead screw actually looks significantly nicer than the lead screw that came on that machine. So, like, this is just the machining on this looks significantly better than the one that it came with. They may have actually had this made rather than pulled off the assembly line. I don't know. There's no center in the end. I was gonna say we could run this between centers and see how it spins. I mean, I guess we could use, yeah, we could use that as a center on this side. Maybe we could chuck this end up in a collet and just see how it spins. So I don't know how they're manufacturing these. I don't know if they're running it through a die or if they're actually making them on a lathe or what, but whatever they're doing, it's not working because this one's got the same issues as the previous one. So swing and a miss from Vivor. All right, and our revised part is done, and all I did was just slope it back there at the top to accommodate for that cable for the DRO. So this should fit now. All right, well, our last little adjustment there on the rear one got that fitting underneath the cable for the DRO just fine, and now all 4 of these are on, and all 4 of them are completely cleaning up all of the surfaces as this carriage goes along. So I can stop worrying now about junk getting trapped between these ground surfaces and the underside of this carriage. Now, there is quite a bit more to do on this machine, so you'll probably see this again in future videos. I mean, we're not going to work on this every single week, but just looking at the front here, I'm noticing there's also no gasket on the cross slide. So as I walk this across, you'll notice we now have the surface exposed, so if chips get on there, they're going to end up underneath this cross slide. And looking at my larger lathe, you can see there is a similar rubber gasket there on the front that serves the purpose of keeping junk out of there. So now when we bring this guy back forward, any chips that were on there are just going to get pushed off, and you can actually see stuff running down the front here that gets pushed off when I'm cranking this guy back. The other thing with this machine, we'll probably do it at the same time, is the T-slots on this are actually really convenient to mount other things on the cross slide, but they fill up with chips. So I want to design something that fills these slots and or covers this. Probably fills the T-slots because I don't think we want to cover this face. I often drop an indicator or a magnetic indicator base down on this. But what I'm thinking for the front here, since there's no holes drilled in this casting to mount a gasket to the front, rather than drill the holes, maybe we can integrate the mounting of that front gasket into whatever we put in here to fill up these T-slots. So that'll be a future video. I picked up quite a bit of tool holders for this lathe as well, and on my other lathe we designed the drawer organization that these all dropped into. On this machine, since these tool holders themselves are quite a bit lighter, I think I'm probably going to design something that mounts up on the back. I've seen a number of other folks do that. I've not seen a design that I like. I want to design something that kind of locks into this and sets them up a little higher. So that'll be a future project that we tackle on this machine as well. That'll probably just be plain old PLA. Well guys, I don't think anyone would accuse me of taking the straightest path on this one, as is usually the case. And I probably got a little bit OCD on the details for the surface finish on these, to get that perfect seal. But I'm really happy with the result that we got in the end. If you happen to be watching this video and you'd like a set of these for yourself, if you've got a 3D printer, you're all set. I give away all the STLs for anything that I design here on the channel. So those will be linked on my site, fpfdesigns.com, and that link will be down in the description of this video. If you don't have a 3D printer, I might make these for sale. I envision this is one of those items where there's probably going to be people that end up watching this video thinking to themselves, man, I wish I had a set of those, and they don't have a 3D printer or are not interested in trying to tune in TPU. So if I do make these available for sale, I'll make sure that gets linked down in the description of this video as well. And if this is by chance your first time here on the channel, this is all we do. It's all functional parts and engineering like this. There's no multicolored doodads of the week or minifigs or anything like that. There's nothing wrong with that. That's just not the focus of what we do here on this channel. So if you're into that sort of thing, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.